Hello everyone, welcome back to this channel. Dear students, today's topic is purely resistive, inductive and capacitive AC circuits. Actually this is subtopic from the chapter single phase AC circuits. In this video I will explain you how to derive the equations of current, equations of voltage, equations of power, and importantly how to draw the phasor diagrams. Many students find it difficult. I will be telling you the clues, some important tricks so that you can easily memorize the phasor diagrams. Now this is the list of formulae which is required for the derivations. In this session, as I mentioned, I will be deriving few important relationships, so do watch this video till the end. Without wasting the time, let us start the topic. The first part is purely resistive AC circuit. How to draw the diagram? Make it simple. As the name indicates, it is pure resistance. Resistive means resistance. So I have drawn a simple diagram. R is shown, which is a resistance. Supply voltage is Vm sin omega t because it is a AC circuit. So I should not only mention it like V. It is Vm sin omega t. I have considered sinusoidal supply voltage. Vm is the maximum value of supply voltage. Now, in this case, to make the thing simple, I will write V is equals to Vm sin omega t. This is the equation of supply voltage which we have supplied to the resistive circuit, that means to the resistor. Now, everyone knows the well-known phenomena, well-known equation from Ohm's law, I is equals to V upon R. V is voltage, R is resistance, I is current. So in this case, I can write equation of current as V upon R. That means this becomes Vn upon R sin omega t. So this is the equation of current. Now, actually, the standard equation is, suppose I want to write standard equation for any AC circuit, then standard equation is sin, let us say I am writing equation of voltage, sin omega t plus or minus phi. Phi is known as the phase shift. But this is the resistor. Do remember like this. In case of resistor, there is no phase shift. So there is no phi term. So the simple equation is Vm sin omega t. Similarly, I have obtained the equation of current by using Ohm's law, Vm upon R sin omega t. Now, how to draw the diagram? Presently, to draw the diagram for purely resistive circuit is the simplest part. I will tell you how to draw the diagram. On the same axis, draw the vertical axis. On the same axis, write it as voltage or current. On the same axis, on the same graph, I am plotting the diagram of voltage and current. On this axis, write omega t. Now, look at the equation of voltage. Say equation number 1. This is equation number 2. It is Vm sin omega t. That means it is a sinusoidal waveform. So, I will draw the sinusoidal waveform for voltage like this. Keep in mind, Vm is the maximum voltage. So, this is the maximum voltage which I will denote it by Vm. This is the starting point. Everyone knows this is the standard sine wave. In case of standard sine wave, this value is pi, this value is 2 pi and so on. So naturally this value will be pi by 2. So this is the way how I have drawn the voltage waveform. Now in the same diagram, I have to draw the current waveform. How to draw it? See, current is basically Vm upon R. It is divided by some value of resistance. So value of Vm, since it is getting divided by some constant value of resistance, will be reduced. So and it is a sine wave. Since there is no phase shift, there is no phi term in this case. Remember it like this. In case of resistor, there is no concept of phase shift. So I will draw one more sine wave, but whose amplitude will be less than Vm. Why less than Vm? Because it is Vm upon R. So similar sine wave, I will draw it. This is the current waveform whose maximum value is denoted by Im. So this is the diagram, this is the graph which shows variation of voltage and current with respect to omega t. This is peak value of voltage Vm, peak value of current Im. Now how to draw the phasor diagram? As far as this chapter is concerned, single phase AC circuit is concerned, every time take this horizontal axis as Vm, take this axis as a reference axis. This is the starting point. So I have drawn a horizontal line which represents Vm. Now, as I mentioned, there is no phase shift, phase difference between current and voltage. So Since there is no phase shift, current will be along the same direction as that of voltage. So along the same line, I will draw IM, whose amplitude, this length of this line represents amplitude of current, whose amplitude is less than Vm. So this is the, you can well write, this is 0 origin. So this is the phasor diagram of purely resistive AC circuit. Very simple, voltage and current are along the same lines. The next part is calculation of power. From the exam point of view, the question can be separately asked to derive the expression for power in case of purely resistive circuit. Now, as far as power is concerned, there are two parts. First part is calculation of instantaneous power. Calculation of instantaneous power, and second type of calculation is calculation of average power. Now, basic equation of power is P is equals to V into I. We have already discussed these two equations, one important part. This equation of I is Vm upon R. This is equation number 2. You can well write Vm upon R. See, Vm is maximum voltage, which is constant term. R is resistance, which is constant term. This value can be well expressed or well replaced by term Im. From the exam point of view, how will you come to know which notation is to be used? Very simple rule. In case of V, look at the expression. V is equals to Vm sin omega t. Vm is what? Vm is the maximum power of voltage. Likewise, this is the expression of current. Whatever constant value you are getting before sine or cosine term, whatever it may be, denoted by, since it is current of I, denoted by Im. So, I can write simplified equation as, in place of Vm upon R, I have written Im sin omega t. This is just to reduce down the calculations. Now, P is equals to V into I. So, in this equation, I will put these values of V and I. V is equation 1, that is Vm sin omega t. I is equation 3, that is into Im sin omega t. Simply, I will write it like this, Vm into Im, and this term sine and second sine term can be replaced, can be written as sine square omega t. Now I have made a list of trigonometric identities. Only these identities are required. So look at the first identity. Sine square omega t is expressed as 1 minus cos 2 omega t upon 2. So I will write the next step as Vm Im into 1 minus cos 2 omega t upon 2. I am making use of first identity. It can be simply written as Vm Im upon 2 minus Vm Im cos 2 omega t upon 2. Very simple. I have taken these two outside. It becomes Vm Im upon 2. Then individual term is getting multiplied with Vm Im upon 2. So it is Vm Im upon 2 minus Vm Im cos 2 omega t upon 2. Now this first term Vm Im upon 2 is a constant term because there is no t notation. T represents time period. So this part, this term is a constant term in the equation of power. This is rather instantaneous power. Whereas the second term contains cos of 2 omega t. T is the time period. So nature of this term is cosine wave and it is changing with respect to time. So it is fluctuating term. This is the equation of instantaneous power. Now the next part is I need to derive the equation of average power. Average power is simply, I will write it over here. Average power is the constant term in the equation of instantaneous power. So average power can be written as P average is equals to, I will consider this term, Vm Im upon 2. Now as far as possible, express average power in terms of RMS value. We know the standard formula. Vrms, that is RMS value of voltage, is Vm upon root 2. Similarly, RMS value of current is Im upon root 2. This is the relationship between maximum value and RMS value. I want to express this equation in the form of RMS values. So I will modify the equation like, I can well write this as Vm Im upon root 2 into root 2. Very simple thing. This 2 can be expressed as root 2 into root 2. Now separately I will write it like this, Vm upon root 2 into Im upon root 2. Just now I explained Vm upon root 2 is Vrms, Im upon root 2 is Irms. Therefore, final equation of average power is Vrms into Irms. This is the equation of RMS power in case of purely resistive circuit. The next derivation is for purely inductive circuit. Now see, it is similar to the purely resistive circuit. What's the difference? In the earlier diagram, we had drawn here the resistor. This is inductive circuit. So in place of resistor, I have drawn inductor. Now, whenever there is one more thing, the supply voltage is V is equals to Vm sine omega t. This is alternating voltage. Whenever there is an alternating voltage, it produces alternating current, which produces alternating flux. And the property of inductance is that it generates the self-induced EMF whenever there is a change in flux. This value of self-induced EMF is given by E is equals to minus L. L is the value of inductance into di by dt. I is the current. Now the basic property is that the supply voltage is negative of this induced EMF. EMF is electromotive force. This is the standard formula for induced EMF in case of inductor. So as I said, supply voltage is negative of this induced EMF, that is minus E, but E itself is negative. Therefore, I can write V is equals to this minus minus sign becomes plus L di by dt. But V is Vm sine omega t. Therefore, I can write Vm sine omega t is equals to L di by dt. What I am supposed to do, I have to obtain equation of current. So I will rearrange the terms. I will write it like this, di by dt is equals to Vm upon L sine omega t. What I did, I have transferred this L at the LHS. So it becomes Vn upon L sine omega t, and then interchange LHS and RHS term. Now this is the equation of di by dt. Whenever you want to, I want equation of current. Whenever you want to cancel out the effect of derivative, the simplest option is take integration of both sides. So I will take integration of this equation. If you take integration and derivative will get cancelled, and I will get I is equals to, since integration and derivative gets cancelled, this Vm upon L is constant, so taken outside the integration, and integration of sine omega t dt. I have written the formula required for integration and derivative. Only one integration formula is required. Integration of sine omega t is minus cos omega t upon omega. So I will get the new equation. It is Vm upon L into minus cos omega t upon omega. This omega is constant, can be well taken outside this equation. So I will write it like this, Vm upon L omega in the bracket minus cos omega t. Now I have to make use of the trigonometric identity. Cos omega t is sine pi by 2 minus omega t. So I will replace it like this, Vm upon L omega. For the simplicity, I will take this minus sign outside this equation. So I will write minus, and in place of cos omega t, I will be using this identity. So it is sine pi by 2 minus omega t. Now little bit manipulation we need to do. This is sine pi by 2 minus omega t. Actually t term should be first and then pi by 2. Pi by 2 is a phase shift. This term should be later on. So to manage this, I will rearrange the equation like this, minus Vm upon L omega, then sine omega t minus pi by 2, and I will write minus sign over here. what I did, I have multiplied by minus 1 to this sine term and to this bracket term. So it becomes minus pi by 2 plus omega t. I have written it like this, omega t minus pi by 2. What I did, I have multiplied this term, I mean first sine term by minus 1 and this bracket term by minus 1. So mathematically minus 1 into minus 1 become plus. I'm just manipulating the equation. So this becomes minus sine, then this is minus pi by 2 plus omega t. I have written it in proper order, omega t minus pi by 2. Now we know that this minus sign and this minus sign becomes plus, so I will directly cancel out this sign. So this becomes Vm upon L omega sine omega t minus pi by 2. In the standard form, if I want to write the equation of current, so just now we discussed in the previous derivation, this is the constant term, this is equation of current. So this constant term can be replaced by the simple notation Im. So Im is the constant term which is Vm upon L omega. Since this is equation of current, I have expressed this constant term by the notation Im, which is sine omega t minus pi by 2. Now a big task, how to draw the phasor diagram. So again, stick to the rules. For drawing the phasor diagram, we need to plot the value of voltage and current. Do remember just now we have discussed equation of voltage is Vm sine omega t. How to draw the diagram? On the same axis, like the previous case, I will write voltage and current. On the horizontal axis, I will mark omega t. So I will first mark some reading. This is 0, then this is pi, this is 2 pi. Since the voltage waveform is a sinusoidal wave, standard sinusoidal wave, I will directly draw the diagram like this. It is a standard diagram of sine wave whose peak value is Vm. It is given in the equation. So it is from 0 to 2 pi. What about current waveform? Very important thing. Actually, standard equation of current related to this equation is Im sine omega t plus or minus phi. Phi is the phase shift. If it would have been only Im sine omega t, like the purely resistive case, then the nature of current and voltage waveform would have been same. But in this case, this term, make the thing simple. Whatever term you are getting after omega t, see, its amplitude is Im, this is maximum amplitude, nature is sine wave, that is similar to this, maximum amplitude is Im. With omega t, this is minus pi by 2. This minus pi by 2 value is known as phase shift phi. Since minus sign is there, minus sign indicates that this is late, this is delayed term. So the phase shift is minus pi by 2. In another language, it will start late compared to the voltage waveform. Late by how much amount? It is starting late by an amount pi by 2. So let us say this reading is pi by 2, this is 3 pi by 2 and so on. So this current waveform will start from pi by 2 because it is delayed by pi by 2. So I will draw the current waveform like this. Like this, and its amplitude is naturally less than Vm because this is a current and current is voltage divided by resistance. So this amplitude is Vm. This is the diagram of rather waveforms of current and voltage with respect to omega t. Now how to draw the phasor diagram? To draw the phasor diagram, again like the previous case, we will take voltage as a reference. So I will mark one horizontal line which represents voltage as a reference. Now current, just now we discussed, current is, I will draw it at another place. Let us say this is the line for voltage. Just now we discussed, current is getting late or delayed by how much amount? Pi by 2. So this delay, pi by 2 is basically 90 degree. This pi by 2 is corresponding to 90 degree. This is the waveform of voltage. Its length is equals to value of Vm. Now current is getting late, delayed by 90 degree, that is pi by 2. So I will show this angle like this. This is the current waveform I, whose angle is 90 degree or pi by 2. This is known as the phasor diagram, and since it is current axis whose amplitude is less than that of V, because Im is less than Vm, so I have shown its length less than that of the corresponding value of voltage. Now let us derive the equation of power in this case. Like the previous case, first I need to derive the expression of instantaneous power. We know the standard formula, power is voltage into current. So this is the equation of voltage, second is the equation of current. Just now we have discussed these equations. So instantaneous power is P is equals to V into I, that is multiplication of these two equations. So I am writing Vm Im sin omega t into sin omega t minus pi by 2. Simply multiplication of V and I. For this second term, I need to make use of the identity. So look at this term, we have identity number 3, sin omega t minus pi by 2 is minus cos omega t. So I will take minus sign outside, I will write it like this, Vm Im sin omega t into, see, sin omega t minus pi by 2 is minus cos omega t. I have taken minus sign outside, so simply I will write cos omega t. Now for this term, sin omega t into cos omega t, we have one more identity, sin 2 omega t upon 2. How will you come to know in the exam that I will have to make use of identities? Very simple, you should have in the final equation, you should have only one term, either it is in terms of sin or cos. There should not be two different terms like sin and cos or sin and so on. So I'm making use of identities. Now for this sin omega t into cos omega t, I have sin 2 omega t upon 2. So this equation becomes minus Vm Im into sin 2 omega t upon 2. I am using identity number 4. So I have got the equation in terms of only one, that is sine term. There are no two sine terms or no sine and cosine term. Now simply this divided by 2 term, I can write it over here. This is just the mathematical manipulation. So this is the equation of instantaneous power. Now what about average power? Stick to the basics. Like the last derivation, what we consider, whatever term that you are getting as a constant term in the case of instantaneous power, from that we are deriving, we are supposed to derive the expression of average power. There is only one term and it contains sin 2 omega t. There is no constant term. This is a time varying term or fluctuating term. There is no constant term. So average power is 0. One more logical reason. If you are integrating sine wave and cosine wave for one complete cycle, answer of integration is 0. But remember it like this. There is no constant term. So average power is equals to 0. This is about the derivation of power for purely inductive circuit. The last type of derivation is purely capacitive circuit. Very simple logic. In the earlier derivation, we had drawn here the inductor. Before that, we had drawn resistor. Now this is purely capacitive circuit. So I have drawn a capacitor. Supply voltage is as usual, V is equals to Vm sin omega t. Now, do remember the basic things. We have the given equation of V, that is supply voltage. I need to first obtain equation of current. How to do it? Use the basic formula. Q is equals to CV. What is Q? Q is the charge on each plate of a capacitor. Capacitor basically consists of two plates. In between two plates, dielectric medium is there. So charge on each plate is C into V. C is the value of capacitance. V is the supply voltage. In this case, V is Vm sin omega t. So it can be written as CVm sin omega t. Now, current I is given by dq by dt. Basic equation of current, derivative of charge. So I will write it like this, d by dt of CVm sin omega t. Now I will take this constant term C. As far as derivative is concerned, derivative is with respect to time. So CVm is constant. So I will write it like this, CVm d by dt of sin omega t. I have written the corresponding formula. Only one integration and one derivative formula is required as far as these derivations are concerned. So we have derivative of sine is omega into cos omega t. So equation of current is CVm omega into cos omega t. Now, if I want to obtain equation in terms of sine wave, because drawing a diagram in case of sine wave is comparatively simple compared to the cos wave. So I will express in terms of sine wave. I have the identity cos omega t is sine omega t plus pi by 2, identity number 5. So next equation will be I is equals to c Vm into omega. In place of cos omega t, I will be putting value sine omega t plus pi by 2. Very simple logic like the last case. These terms, I mean Cm, Vm into C, Vm into omega, whatever terms are there before the sine or cosine is denoting the constant term. Since it is equation of current, I will denote it by Im. So I is equals to Im, that is maximum value of current, sine omega t plus pi by 2. Now observe the difference. In the last derivation we got here minus pi by 2, that was indicating delay. Delay is also called as a lagging. So how to remember the things? If it is inductor, notation of inductor is L, then it is lagging. So in the earlier case, the current was lagging by an angle pi by 2. Here we have the plus sign, opposite sign to that of earlier case. So we can say that in case of purely capacitive circuit, current leads by an angle pi by 2. Now we have the standard formula of V, that is Vm sine omega t. How to draw the diagram? Same logic like the previous case. On this axis I will write omega t, on this axis voltage as well as current. First I will draw the standard waveform of voltage. So it is a sine wave like this. This value is pi, this value is 2 pi, in between somewhere I will be having pi by 2, this is 3 pi by 2. I have marked the scale. This maximum value of voltage is Vm. Now, this current is Im sine omega t plus pi by 2. Just now I have explained the concept of plus sign. Plus sign indicates a leading. That means it is starting earlier. By how much amount? By an amount pi by 2. Voltage waveform starts from 0. So before that, by an amount pi by 2, the current waveform should start. So let us say this is reading of pi by 2. I will mark minus sign over here because this is the reading before 0. So pi by 2. This is minus pi by 2. Now actually it is leading by factor pi by 2. On the scale, this is at the negative side, so I have marked a minus pi by 2. Current waveform will start from this value like this, and its amplitude is less than value of maximum value of voltage, so this value is Im. This is the way how you can draw the voltage and current diagrams. You don't have to mug up any diagram. From the equation you are in a position to draw the diagram. Now the phasor diagram, similar to the previous case, take V as a reference. So this is axis of V, its length is equals to Vm. Current in this case is leading, plus sign indicates leading. So current is leading by an amount pi by 2. So for current I will mark one vertical axis. I will write this value as I, and this angle is pi by 2, that is 90 degree. So in case of capacitive circuit, the current is leading than voltage by an angle pi by 2. So this is known as the phasor diagram. These are the equations of voltage and current. I have written it for the ready reference. Now the remaining part, last part of this derivation is calculation of the power, like the previous two derivations. First we will be calculating instantaneous power. Everything is same, only values are different. We know that power is P is equals to V into I. Put the values there for P is equals to V is Vm sine omega t into I is Im sine omega t plus pi by 2. So this can be written as P is equals to Vm Im sine omega t into sine omega t plus pi by 2. Now just now we discussed this identity. Sine omega t plus pi by 2 is same as cos omega t. So I will replace this term by cos omega t. So it becomes P is equals to Vm Im sin omega t into cos omega t. Now cos omega t into sin omega t, sin omega t into cos omega t is sin 2 omega t upon 2. So we can replace this term by a single term, that is sin, I am using this identity, sin 2 omega t divided by 2, I will write 2 over here. This is the equation of instantaneous power in case of purely capacitive circuit. Now there is only one term, there is no constant term. So this term which is present in the case of instantaneous power is changing with respect to time because it contains t term. There is no constant term. We know that average power is related to constant term. So average power in this case, that is in case of purely capacitive circuit, is 0. So dear students, this is the derivation of purely capacitive circuit. So I have told you the simplest technique to derive all such equations. You don't have to mug up these derivations. Logically, you will have to derive the things. So that's it for today's session. If you like this video, please smash the like button. Thank you. Thank you very much.